And then we talked about a little bit on Unreal. We created a project and we talked about how we should approach this blueprint stuff. Like first creating C++ classes, then deriving blueprints from them. We logged something and my IDE doesn't work, so we again waste some time when I try to make things work on VS Code. And we tried setting up lights and it just doesn't work. I mean, I just couldn't find the menu, so I will try to find it again, show you how to do so. By the way, this is our new project. I mean, I just changed a few things on GitHub repository, so you should just clone the things. So let's start from here. Let's create a new folder for our project. Let's call it test project. One more folder for levels. Yes, and let's create an empty level. Let's call it main and open it. Okay. Now again we don't have any lights, so the menu was here, but okay, there's something weird. The menu just shows up in my left screen. So if you have Unreal on your end, you can give it a try. It is under window and there is something called environment light mixer. So when you open this environment light mixer, you can just create some default lighting with this, and that. Yes. Okay, so we will start from variables again because we should know more about them. So for this one, I will close the Unreal and continue from Unity because after this session we will make some practice and we can do the hard stuff on that. I don't want to waste anyone's time right now. So let's talk about variables again. On our first session we did something like this, right? We just logged a few things like this. So this was our example. I mean, something very close to this. So let's talk about those variables scopes. So we call this variable local. What do we mean by local? Local is just living inside this start method. Okay, let's debug this program in our minds in imaginary way. Okay, let's assume we have this test script in some game object and trigger start function. Okay, then it creates a place in memory to hold this integer and debugs it on the console. And when this method is just end, we don't have this variable anymore. So variables lives in their scope, and this is its scope. It just automatically destroyed on. Let's make a string and call it name. Okay, so name is living in this scope. Okay, so you can understand it from the curly brackets. So when I debug it on here, this the name, sorry, I just got my name. Okay, actually, by the way, it's a good coincidence. You shouldn't use name as a variable name because name is already reserved by Unity. Name has a different meaning on mono behavior. Let's call it my name, Anyway, so we can reach this variable from start, from update, but we can't do the same for the age, right? It's not applicable on C#, but in C and C++, you can just define a variable here. It is not under a class or struct, etc. So this means it's just global. If you can reach this script, you can reach this, then it means you can reach it from anywhere. We call them global variables. We also have this accessor stuff on object oriented. I will explain them in depth, but it will be in a late stage. We shouldn't think more about this object oriented stuff, but we should know this. When this is private, we can't reach it from outside of the class. Let's create a class and make its name a class. Okay. It is not deriving from mono behavior, so we can't just drag and drop it to our scene. Okay, so we can put our test script here, but we can't put this a class to here because it's not mono behavior. These are just derives from mono behavior, so they are integrated with Unity. So that's why those methods are called automatically. Let's continue to our example. Let me okay, let's call it sum value, and let's call it sum string. So now, as we just instantiated an integer, we just reserved some memory for an integer. We can do the same thing for a class, but this is a little bit different syntax. I just reserve some place in the memory, and if we want to reach some values of it, we just be able to reach some string, right? Because it's public and we can't reach the sum value. Since this was public, I was able to assign some value it, and I can't assign some value to some value. And the motivation of this is like they want to control how you reach and manipulate data, right? That is why they have some another jargon like accessors and mutators. So let's say I want to change this sum value. Let me rename it. They just make some stuff like this. Like this. Okay. They call it mutator. So you are not allowed to directly change this value, but you have an interface for reaching it. Like right now I can reach it and give it a value, and if I want to get its value, I can write an accessor get some value. We don't take any arguments to it, and we can just return some value. And now if I want to get my value, I can write something like this. So let's talk about its benefits. For example, let's say you want to control how your software works because you want to handle errors and make some validations. Let's take it as an example. If we want to make some value between, let's say, 50 and 100, we can push our users to do so. Like if value is greater than, so I can give an error here, right? It must be, wait, what are you doing? Let's assume you are working with a team and you want to make some restrictions, okay? When you do this, and let's put a return here. So when you do this, you can restrict any value less than 50 and greater than 100. So there are some shorthand for it. Let's say some other value. So this line is same thing with this. Let's comment it for a moment. Okay, so this is the object-oriented religion, okay? They just do it to encapsulate things. They want to be very secure about accessing data or changing data. So they usually use this jargon. For a member variable, they just use this jargon, okay? Rarely they use those kind of conditions, or let's say we want to show a message, right? We can control this from these accessors and mutators. for making it practical, they have this. It is short way of doing this. But if you want to customize the behavior for getting and setting data, you can do something like this. How was it? Like this. You can do this. This is also same thing, and the other one I just showed was the shortest way of doing this. So this one is a keyword, okay? What do you mean by value here is, let's go back to our test script, and when I press A, which was our class, now we see something here, right? It has a different icon, and this is called a property. Let's remember the jargon. If a class has some variables, we call it member variables. If we use some accessors or mutators for it, if you use this jargon, this get set jargon, which is totally same with this one. If you use this jargon, it is called a property. Okay, so you can differentiate it from its give a value to this one. This means set. But if I just get this value, like my value is a nocta some other value, this means get. This is the accessor version of the property. This is the mutator version of the property. Constant. There is also another keyword. It has many different meanings on C++. In C#, it's just guarantee that this value won't change on the runtime. Okay. Assume you have some stupid people in your team, okay? So you wrote some math libraries and pi is like 3.1 for blah blah. And if there's some idiot on your team, they can change it. Okay, in C#, you reach them from the class, not from object. You see, we were changing these values from object, which is an instance of the class. So if you want to reach these constants, you have to reach them from the class name, and you can't change them. Let's try it. And by the way, we can split the screen, so yeah, it's much better. So if you want to give it another value, you see it just says constant is immutable, so you can't change its value. And there is one more keyword which is static. Let's say public static int, let's call it count. Okay, we were talking about boxes, right, in our first session. I said when you create a variable like integer a, I always use this metaphor. You just create some box in the memory, right? And it is the same for classes. So when you create an object from a class, let's call it our class was a class, and let's call our object a class object, and let's assume it has more data. This is an object. This is instantiated based on some design, right? And we call this design a class. Okay, so you should understand the difference. It's very important. Class is design and object is its real version. I mean, it's something real. This is not design. It lives and dies in your program. Okay, so in your class, when you create some member variables, when you design your class like this, when I do this, this means that any object from that class will have a member variable, and we will call it my name. Okay, so when I instantiate an object from that class, actually you can think it has another box inside of this class. Okay, like my name. This is clear, right? So the static thing is a bit different. Let's see our values. Okay, we have a static variable in our A class. We call it count, right? When this program runs, it just create a box, another value. I mean, let's assume it just put this box inside the design, not the instance. Okay, so let's call it count. I mean static count. So if we have 10 objects from this class, we will have 10 my name members, right? But we will always have just one count. If we have 100 of objects, we still have one count. And this has some benefits. Count is a very common example for this stuff. Let me simplify things. Okay, this class has a count variable and a my name variable. I won't use those accessors mutators right now. We are not teaching object oriented. I will try to simplify things. Let's create some objects from this class. So I'll explain one more thing. It is also common jargon in object oriented. So this is default constructor. When you create some objects with new keyword, actually what you do is you just call this method. Okay. If you don't write anything for this method, then reserve for enough size of memory. But if you write this, every time you instantiate a object from a class, this method will be called. So let's write something like this. Hey, I am instantiated. Alright. So we created 3 objects. Okay, you see, it is just called 3 times because our test script, the left one, creates 3 objects from this class. So let's change it a little bit. Let's assign some values. A. Okay, so we intuitively know each of them has different names, right? Let's debug them. Names are okay. And let's debug the static variable. Count of A class dot count. Okay, this is just one thing and it is just one more important point about this static is you don't have to instantiate any object. I mean, it is still there. When you just run your program, this is there. You know, you don't have to instantiate it. It just here. You can't remove it. You can only change it. So common practices. Why I named it count? So people usually use it like this. Let's say I just increase the count of this static count. So when I instantiate 3 objects, now I don't have to think about increasing count, blah blah, because in my constructor I increase it one by one, and in anywhere of my program, let's say we talked about those local variables, right? We can't reach them from here, right? But I can still reach our count from here. Instantiated object count is, so when we press, see, I can reach this value. Actually, those objects are just died because their scope is ended, so they are removed from memory. The garbage collector thing takes care of this. We can also write a destructor here and decrease the count, but do you understand the benefit? We can reach it from anywhere. When I do something with Unity, I usually prefer some controller classes. For example, some managers of spawning things, etc. It is also a common practice. Let me give you an example. Let's create some game objects. Okay, let's change it a little bit. Okay, our sphere has, hey, I am sphere. Okay, this script will define our spheres, behaviors, and values, etc. And what can our sphere do? Let's change its position randomly. Plus rand. Actually, let's make it between negative and positive one, so it can dance like crazy. Okay, so let's see how it will behave. Yeah, where are you? Okay, here is our crazy sphere. Actually, we can multiply it with delta time, so it will be a little bit smoother and slower. So we can see what it's doing. Okay, it's just shaking. So let's make a prefab from this sphere and create another class which just spawns spheres. Okay, sphere spawner. Let's call it sphere spawner. So we will put a prefab to instantiate, and let's put a timer. Okay, let's call it timer, and we will increase the timer on each update, and if timer is more than 1, we will zero the timer again, but at the same time we will instantiate from our prefab, right? We will just drag and drop our prefab and it will instantiate it. And since our sphere prefab has I am a sphere mono behavior, it will start to shake, you know. Okay. We need to randomize because they are so close. Okay, forget about that and let's multiply it with some random range between. No, sorry. We must do this in another place. If we do it on update, it will just shake crazily. But let's make it on start. We will define this position like what higher? No. Okay, it just take the C# vector. I want unities vector. Okay. Vector tree 1 multiplied by a random range between. Okay, this makes more sense. It will spawn the sphere at a random position and the sphere will start to shake. Okay, let's rename it again, sphere spawner. So on each second we will spawn another sphere, right? And they will be in random positions. Where are you? We can do like this. Why they are always in the same position? Hmm. Okay. Because we are setting it here. Okay. Let me think about it. I think we should do something like this. Like my local position is changed by this amount. So actually we can use also position. So we will change our position randomly, but our start position is also different. I think this can fix it. No, actually -1, +1. We just want to make it move, okay? What I want to do is spawning them in different positions. So what we did wrong was when I just make it equal, it just always, position it at a unit square space. But right now we just manipulate its position from its start position by the way, do you all know this? Like, let's make it. So instead of this, you can do it, right? So do you know this notation? Do you all know this notation? This plus equals means, yeah. Add myself to the equation. Okay. So let's see our randomly spawned shaking spheres. No, it's not increment operator. Increment operator is this one. When you do this one, it is something different. Yeah. Okay, here is our randomly where are they going? Okay. Let's make it a little bit smaller. Let's do this and we will finish our first session. And 10 minutes later, we will start some random coding about our projects. Where is our spheres? Why they are always using the same path? Okay. They don't. They just randomly split. Okay. So we were talking about statics, right? Let's move on to that issue. I did all of this just to explain statics. So let's assume those spheres are your bullets on the game. Okay. And let's assume you have another class which holds your game stats. Okay. And you are counting how many bullets are used on each level. Yeah, you just want to entertain your player and you will show a screen at the end of the level like you just used that amount of bullets. Okay. So if you want to do this in another class, how can you do it? I mean, let's do it in hard way. Let's call it bullet count and even make it public, and we will always log the bullet count. So this must be somehow related with this sphere spawner, right? So you have to take a reference to your game stats, right? Game stats. And from this reference, every time you instantiate a sphere, you can do something like this. My game stats bullet count increased, right? This is a bad way to do this, you know. We did this and now we have to put its reference to here, our game stats reference to our bullet spawner, and let's assume you want to hold like 100 stats about the game, and so this is not a good idea, you know, just putting a reference to it, other one, this one, just to hold values. So this static stuff can help you about this. Let's put a public static int sphere count. This is our static variable, right? And let's just increase it on stat. So anytime sphere is instantiated, the sphere count increases. So you should always think like this. If you can remove some code, then probably you are doing something right, okay? Right now, we don't need this bullet count anymore, right? We are probably doing something right. Our class was hey I am sphere, and since it's static, we don't need object, we can't reach it like this. And in the sphere spawner, we also don't need this. We able to remove one more thing. Let's make it collapse. So now we don't have to think about references or forgetting to drag and drop something. We just make the connection in a higher level. These statics are also used for one more thing, but should I explain this or should I finish? Okay, we still have 4 minutes, so I'll explain this one too. Let's assume another scenario. Yeah, we said we don't want to drag and drop game stats to each other object, right? It will be some extra work. But let's assume you want to reach the game stats from anywhere. So you can create a static reference to it. And let's call it instance. Okay. This is just to give you an idea. You don't have to understand it totally right now because it's actually a bit complicated. So this is a static reference, and when you instantiate your first game stat, it will check it, and if it's null, it will show our instantiated game stats. So this is a very primitive way of designing a singleton pattern. Okay. So what is the benefit of it? Let's say online players. Okay, let's assume our start class holds the online player count, and let's assume it's 10. So we won't create another reference, but we can reach it like this: game starts dot instance, right? Because this is the class name, this is a static variable name. So it is totally the same thing with imsphere dot sphere count. It's a good way to use it. We should be able to reach our online players, right? Very easy. It cleans up your code. I didn't take a reference. For singleton objects, you are guaranteeing that you will instantiate just only one in your game. Let's think about the chess game, okay? If you instantiate a chessboard in a chess game, you don't need to instantiate another one, right? So you can make the chessboard singleton. So you can use that only one instance of that chessboard. There's no way to play chess with two chessboards, right?
Hey, cool. I get to ask questions in voice. I'll go first. I just thank you so far. A question about the types of classes you have, or excuse me, public means it can be used outside. Private means it can only be used inside. And then you had constant, meaning it can't be changed outside again, even in multiple objects. And then you just explained static. Can you summarize the difference between static and the other ones for us? Like brief summary.
Sure. So anything except actually we should categorize what we talked about. There is some accessors, right? We can use public, protected, and private. Those are accessors. Those can be in front of, I mean, as a prefix to any variable type. So there is also just two keywords we used, like const and static, and the rest of the formula, like integer a, blah blah. So this one is about your reach level. Let's say if you make a member private, you can't use it outside of the class. I mean, let me show. So this is inside of the class. If you write some methods here, you can use this private member, but no one can reach it from outside of the class. Let's assume you instantiated an object from this class somewhere. I think we did it. Yeah. You see, it's my name. We are able to reach it because it's public. Okay, this is the public private part. Const is actually, const doesn't have so much meaning in C#. So we will explain it more in C++ and C. It has some more meaning, but const is just simply guaranteeing that I won't change this value on runtime. Okay, if you put a const to something, you have to give it a value, and no one can change this value on runtime. This was the const part. And lastly, the static part is even it's a member of this class, this variable just have one instance, and you don't need to instantiate any object to reach that. Okay, if I don't instantiate any a class, I can still use the a class.count because it's static. You know, when you start your program, it's there. Its memory is already allocated. You don't need to create something with new blah blah. It's there and reachable. I mean, you can of course make it a private static. It's a rare usage, but it's still used. But so now it's still there, and there is only one instance of this count variable, and it can be reached inside this class, but you can't call it from here right now because I just made it private, you know. The important part of this static thing is it is somewhat independent from the object. It's there without instantiating any object. It is like global, you know, and it's only one. I mean, there is no another a class dot count in the memory. There is only one a class dot count in the memory. When you reach it, when you change it, you always reach the same thing.
That makes sense.
Sure.
Thank you. That does help a lot, actually.
I am also thinking about explaining all this memory stuff in some C code, because I think people really miss that part. So everything becomes more and more mysterious. You know, why there is this, why we use so much parentheses, and why we, for example, this doesn't make sense to me, just using this accessor shit, you know, like I will make my member private first, but I will create a public method and call it to reach it. It's just overcomplicating for me. And if you understand how those variables live and die in the memory, how they allocated, and C language is a very good way to learn it.
I have another question, but I don't want to take up the full space here.
No problem. Just shoot.
This is kind of going back, maybe more Unity question. You used
Mhm.
vector 3 to control the
Sorry,
position.
I couldn't hear. Can
Oh,
you repeat?
yeah. You used, this is a Unity question. You used vector 3 to control the position of the sphere. Why did you use specifically vector 3? Where'd that come from?
Yes, it's a good question. By the way, we will make other sessions about this. I was just using it for giving an example. So if I just skip those kind of things, you can just how can I say, just abstract it. You know, okay,
Yeah,
there is something
it
called vector
relates
3, and
to
we can hold the position. Yeah, but let me explain. So, what is transform? Do you know what is transform? How can we write transform and we can reach a few things? I mean, do you really know what is transform? Let me explain. For each Unity class, we are just inheriting from something called mono behavior, right? It is actually another class. Like, see, we wrote a class here, right? It's called A class. Let me explain it. Now you will totally understand what it is. Actually, those must be, and let's call it vector 3 but with K. Okay, this is our authentic vector 3. So, and let's make another class called transform but with 2m. Okay, and assume this class has something called vector 3 and we call it position. Okay, so this is what you see here. When you just write transform here, actually you are reaching something called transform from mono behavior. And this transform has a vector tree which named like position, you know, this way. So let me use my transform and my vector tree. Let's create a transform but with 2m's, my great transform. And I created my great transform, and my great transform has position. Okay, so what is a position? Position has just 3 float values, x, y, z. This is what we do here. It's when you, let me show you. Okay, I don't want to. When you press that, you see 3 float values here, right? So those are just its member variables. It's the same. Actually, this is a struct, but let's skip it for a moment. It is the same thing with this one. We are just holding three values. Do you remember I mentioned something called properties? Like we can create properties which make this get set stuff. See, these are also properties. I mean, there is really nothing magical about vector tree. We have name A. Okay, what is this? What we did here? We just did the same thing with. If I create a constructor for vector tree which can take three float variables. Okay, this is Unity's vector tree and this is my vector tree. My vector tree is also have the same kind of constructor, so I can use it same way. Yeah, this is nothing more than that, you know. If you are asking about this var pos stuff, if you are asking about this part, this is just like JavaScript notation. If you are pretty sure about the type of the right side of the equation, then you can use varting, because let's say we know it's an integer, so you don't have to write int. Instead of we can write var. So let's say you have some very long class names and you don't want to write here very long, you can use var if you are pretty sure about the right side of the equation. Okay, I didn't read, but yeah, okay, that makes sense. There is nothing specific about Unity actually. I really suggest all of you to learn some C. You will understand everything. It's like being the Neo in the Matrix, you know. You will just see those green codes. Anyway. Okay. Okay. Let's give it a break. Then, if you want, I mean, if at least one person wants to continue, I will continue, and it won't be about new topics. It will be about practicing, you know, so that we can separate this lecture and practice thing. C makes it easy to shoot yourself in the foot. Yes, C++ makes it harder, but when you do, it blows your whole Lego. I I think C++ is like a college student which just take too much drugs, you know. It's just crazy. I don't like the C++, to be honest. I like it more than C sharp. C sharp is like for babies, but we are all grown ups. C++ is overcomplicated. I don't think we need all of the C++ features, and I am pretty sure many of the people are not aware of each feature of the C++. It's just a mess. It's just a big spaghetti, you know. Let's think about Unreal C++. Unreal C++ is not same C++ we use on other stuff. They they wanted to prevent this blow your whole Lego thing, and they create their own C sharp in a different syntax, and they still call it C++. You know, if you do something wrong in Unreal C++, you will get tons of errors and your editor will crash, etc. They are all C sharp style things, like you can't do this, you don't do this, okay, you should write this way, etc. Yeah, Unreal Engine source code is, I think it's more than 80 gigabyte. Yes, practice sessions will be recorded. For example, we covered some stuff here. I will first show you the studio way of doing things. For example, I am just writing here ASDF, but there are some common practices with, how can I say, code standards and some common stuff, you know. I will show them. And if there are still someone after Unity and Unreal, I will show some C code. I would like more stuff about Unreal in the future. Yes, I just choose this one today. There is no specific reason. Okay, after this session, actually it will be better. I will do all of the same things in Unreal Engine on the second part of the session. Okay, so you can see how it goes in Unreal Engine. It's almost same, by the way. What makes other languages better than C Sharp? It's a good answer. C Sharp is garbage code. C Sharp just prevents you to do things. Okay, they have some very goodly optimized libraries, methods, and short ways to do things, but you don't have all the power. C++ or C is not that hard, really. I think we are exaggerating things. I mean, their syntax are hard, but other than that, actually I think they are easier, you know, because, for example, in C,
I think
there are just 10 or 20 keywords, nothing more than that. I mean, you can't learn C for 5 years, you know. But if you are using C Sharp, you have to follow new standards, .NET 7, .NET 8. Okay, what is changed? What is this keyword? Well, you know, it's just overcomplication. My personal opinion, by the way. I mean, you can still write terrible C++ or C code which are slower than C Sharp, but if you have some high goals, you can't use C Sharp. I can say the same for Python. Python is the worst performance I've ever seen. It's really trash.
oh, we ever tried Ruby?
I didn't try.
Ruby's really nice to write, but it's so slow.
Yeah, actually, it's understandable because if you are, I mean, people miss that part. Actually, the only thing you do is when you are writing code, you only send instructions to CPU, right? And CPU has some limited instructions, like you can move data from here to here, you can aggregate them here, and anything other than that is just adding more things. If you write some easy code, then it means someone in the background, I mean, let's the compiler or do the hard work for you, and it doesn't know your specific needs. It must work for everyone. Use this, you know. It's not specifically designed for you, and there are some abstractions layers.
It's once you figure out how the programming language relates to the hardware itself in terms of memory and registers and things like that, then a lower level language like C makes so much more sense.
Actually, yes. I mean, it is speaking almost the same language, you know. It's
Yeah.
really close to assembly one.
Yeah, sometimes you need to know that something happens in a very specific way, and you just can't do that in a very high level language like Python.
I can give an example for this. I think those C Sharp, Python stuff, they are like Guitar Hero, you know. They have they have some 5 or 6 buttons, and it sounds good, okay, but it's not the real guitar, you know. it it doesn't have all the functionality. It just have templates. And again, I'd like to emphasize that it is not that really hard. All those C and C++.
It's just a lot of typing. Everything's very verbose.
Yeah. If you change your expectations from programming, after a point, it just becomes normal. But if your normal is like C sharp, then okay, you feel terrible when you use C or C++.
I had a project a few weeks ago where I was switching between working on the back end of a web application in C++ and the front end in TypeScript, and I was getting so confused. Every time I changed, it would just be a big ball of syntax errors.
Yeah. I understand that. Yeah. But it's really not that hard. Actually, I believe we are learning those programming languages in the wrong order, because if, let's say, you are not able to write some programs easily with just 3 months of education, but let's say you invest 2 years to C or C++, then you can write any code on any language. I'm very serious about that. You can really write on any language.
I think this is probably a good place to wrap up, seeing as Iris is recording, and we should probably get that finished so we can edit it.
Can chat later. Okay, I'm closing the stream.